In today's tutorial, we'll be looking at molar mass. Now, molar mass is the amount of grams or amount of matter it has per the amount of moles. So for molar mass, in the name it tells you its unit. Molar has to have moles, mass in grams. So it's the amount of grams per 1 mole of the substance. Now for this tutorial, you will need to have a periodic table. Now, reading your periodic table, it depends on which one you have, so make sure that you look at the key. For my periodic table, you'll see that we're going to have its atomic number on the top, and we're going to have its atomic mass, or what we're now going to call our molar mass, on the bottom. Now, our first example is H2O. When you have a subscript, it lets you know how many you have of it. Now, when we look at this example, it's telling us that we have 2 H's per 1 O. If there's no number, it represents that it has a 1. So what I like to do in the first is list all my elements, and then right next to it write the subscripts it has. So H has 2 times whatever its atomic mass is. Oxygen's just going to have 1. Now, as a beginner, I suggest that you keep the 1. Once you get more in depth with molar mass, or you feel more comfortable, you don't have to have that 1. So now if we look on the periodic table, we'll see that some of them have more digits than others. Now, my rule of thumb, which I tell my kids, sorry it's kind of blurry on the camera, I'll write it up here, is that hydrogen is 1.00791. I like my students to go out to 2 decimal places. So the 7 is going to round it up to 1.01. We're going to multiply it times 2, so it's going to be 2.02. Now when we look at oxygen, we're going to see it at 15.999. So we go at our 2 decimal points, but a 9 is going to round it up to a straight 16. That one will be pretty easy to remember. So we'll multiply it times 1, and then you're going to add up what you have. So subscripts mean you multiply it times its atomic mass from the periodic table, and then you're going to add all the components in this compound. So we're going to have the molar mass of H2O to be 18.02 grams per mole. Now you could write it like this, or you could have 18.02 grams per 1 mole. Now, when we start writing it like this, we're going to start to use it as a conversion factor. And you are done your first molar mass problem. Now, let's look at our next one. We have our copper 2 sulfate. Now, with this example, you're going to see now you have a polyatomic. So if there is nothing behind, it represents a 1. So for our Cu, we're going to have 1. Our S, we have 1. And our O, we're going to have 4. So let's look up Cu on our periodic table. It's going to be 63.546. Depending on your periodic table, it will also depend on your number. So if you're slightly off, that's okay. So I'm going to go to my 2 decimal places, and we're going to put 63.55. We'll see that sulfur is going to be 32.06 on my periodic table, and oxygen, from our previous example, we found out that it was 16. So luckily these both have 1, so we're just going to carry them over. So you go through the same process whenever you're trying to complete molar mass. So we're going to do 4 times 16. Now you could put it in your calculator, but this is kind of mental math. So we're going to have 64 here. So let's add it up, because remember, we're going to multiply times whatever the subscript is, and then we're going to add it up in our compound. So I'm going to get out my calculator. So we're going to have 64 plus 32.06 plus 63.55. Now we're going to come out with an answer of 159.61. Now all we need to do is write its unit, and it's going to be grams per 1 mole. Now note how I keep writing whatever number we just calculated next to the grams. This will become important when we start doing a little bit of mole conversions. Now let's try our next example. We have aluminum nitrate, but instead of just having a regular polyatomic, we now have an extra digit back here. Now we can see that this 3 looks like it only is affecting this nitrate. So aluminum still is going to have 1, N has 1, and O has 3. So we're going to distribute it back. So it really means that we have 3 N's, and it really means that we're going to have 9 O's. So let's list it down here. Al is equal to 1, N is going to be now 3, and O is going to be 9. Now we're looking at my periodic table. I have 26.98 for aluminum. Nitrogen is 14.01, and oxygen from our previous examples is still 16. Now we're going to multiply across. Now aluminum, not too bad. We're just multiplying it times 1. So we're still going to get 26.98. For the next one, we're going to do 3 times 14.01. And we're going to get 42.03. And we're going to do 9 times 16 and get 144.00. Same way that we did before, we are now going to add up all our values. So we're going to have 144 plus 42.03 plus 26.98. Our answer is going to come out at 213.01. The only thing we need to add on is our grams per mole. Just as I did in the first example, you could also say 213.01 grams per 1 mole. Kind of hinting to our next tutorial on moles. And let's try our last one, sulfuric acid. Now we have our 2 here represented for our H. Our S only has 1 and our O has 4. So same way that we did before, we're going to do H as 2, S as 1, O as 4. So we're going to do 2 times 1.01 to get 2.02. We're going to do our S as 32.06. And we're going to do our O as 16. So 4 times 16 is still 64. 32.06 times 1 is still 32.06. We're going to add them all together. So get out our calculator. 2.02 plus 32.06 plus 64 equals 98.08 grams per mole. Okay, and that's how you calculate molar mass. Look forward to the tutorial now using this molar mass for mole conversions and in the future stoichiometry. Have a good day.